Hello, we are from Group Upsilon. In this video, we are going to discuss about the topic of matrices. Our learning outcome is computing the inverse of a non-singular matrix using the properties of matrix A multiplied with matrix B equals a constant multiplied with identity matrix. K is the constant and I is the identity matrix. What is identity matrix? Identity matrix is a diagonal matrix in which all its leading diagonal entries are 1 and denoted by capital I. And these are the examples of identity matrix. Could you notice that the leading diagonals entries are 1 and the rest are 0? Basically, we have three properties of inverse matrix. Firstly, the inverse matrix of an inverse matrix of A equals to matrix A. Second, the inverse matrix of a transpose matrix of A equals to the transpose matrix of an inverse matrix of A. Thirdly, the inverse matrix of multiplication of matrices A and B equals to the inverse matrix of B multiplied with inverse matrix of A. We should note that, first, if matrix A multiplied with matrix B equals to matrix B multiplied with matrix A equals to identity matrix, then we can say that B is the inverse matrix of A. Next, matrix A multiplied with the inverse matrix equals to the inverse matrix of A multiplied with matrix A equals to identity matrix. Thirdly, the inverse matrix of A is not equals to 1 over matrix A. Look at the questions. Given matrix P equals to 3, 2, 6, 1, 1, 4, and 1, 1, 3, and matrix Q equals to 1, 0, negative 2, negative 1, negative 3, 6, 0, 1, and negative 1. Find the multiplication of matrices P and matrices Q and hence determine the inverse matrix of P. First of all, we have to substitute the matrices P and Q and perform the multiplication. Substitute the matrices P and matrices Q and perform multiplication, and next we will get the answer, which is equals to 1 0 0 0 1 0 0 0 1, which is an identity matrix. Next, we have to determine the inverse matrix of P. Since there is a hence in the questions, therefore we have to use the properties of AB equals to KI because the hence gives the meanings of using the previous answer. So write down the equation where PQ equals to constant multiplied with identity matrix. Next, substitute the matrices P, Q, and identity matrix into the equation to find the constant K. Substitute the matrix P, substitute the matrix Q equals to constant, and substitute the identity matrix. From previous answer, we already found out the multiplication of matrices P and Q. Substitute the answer equals to K and substitute the identity matrix. By comparing both sides, we can determine the K equals to 1. Next, substitute the K into the equation where the matrices P multiplied with matrices Q equals to 1 multiplied with identity matrix. Simplify the equation where the multiplication of matrices P and Q equals to identity matrix. Next, multiply both sides by the inverse matrix of P, and for the right hand side, the inverse matrix of P multiplied with identity matrix equals to the inverse matrix of P. And next, rearrange and rewrite the equation. For the left-hand side, the inverse matrix of P multiplied with the matrix P equals to identity matrix. Rewrite the equation, and for the left-hand side, the inverse matrix multiplied with matrix Q equals to the matrix Q. Rewrite again the equation and make the inverse matrix of P as a subject, where the inverse matrix of P equals to matrix Q. Next, substitute the matrix Q, where the inverse matrix of P equals to 1, 0, negative 2, negative 1, negative 3, 6, 0, 1, and negative 1. And last, thank you for watching. That's all.